Now we are going to talk about the reciprocal, the quotient, and the Pythagorean identities. We did talk about these earlier in the year after the summer review. These are my favorite 11 identities. That might not be true, but they're still pretty good, pretty high up there on the list. So 11 trig identities that we need to know and memorize and love. So first, what is the reciprocal of each of the following? So what is the reciprocal of the number 2? What is the reciprocal of the number 3/4? I want you to pause the video, answer those. Unpause when you're ready to check. Very good. So the reciprocal of 2 is 1/2. The reciprocal of 3/4 is 1 over 3/4, which is 4/3. Okay, that's going to help us. So our reciprocal identities, we've already talked about this, which trig functions are reciprocals of each other. So first, I have sine of theta is 1 over the cosecant of theta, which therefore tells me that cosecant of theta is also 1 over sine of theta, right? If one is true, the other has to be true. Yeah, crazy. And cosine of theta is 1 over the secant of theta, if and only if the secant of theta is 1 over the cosine of theta. And then last, but certainly not least, tangent of theta is 1 over the cotangent of theta. And cotangent of theta is 1 over the tangent of theta. Alright, so these are the reciprocal identities. In this form, they are always true. Okay, we can manipulate them, but then it's not necessarily an identity. Keep that in mind. Alright, what does quotient mean? Well, quotient came up when we did division. Quotient is the result. Let's just do that. Result of division. How do sine, cosine, and tangent relate to the coordinates on the unit circle? So pause the video and see if you can remember that. How do sine, cosine, and tangent relate to the coordinates on the unit circle? You should know this. Alright, so we know that sine of theta equals y, cosine of theta equals x, and tangent of theta equals y over x. And this is relating to the coordinates on the unit circle. But wait, hold up. Wait a minute. If tangent of theta is y over x and sine of theta is y, then this is actually sine of theta over, and cosine of theta is x. Oh my god, look at that. Cosine of theta. That leads us to our first quotient identity, which is tangent of theta is sine of theta over cosine of theta. The other quotient identity, there are two, if you will, is cotangent of theta equals cosine of theta over sine of theta. So you can understand that because tangent and cotangent are reciprocals of each other, or because cotangent of theta is x over y from the unit circle. It all relates. These are not new things. Don't think of this as something new you have to memorize. It's just something you are further understanding. Last, Pythagorean identities. 3 of these. Good ones. What is the Pythagorean theorem? A squared plus b squared equals c squared. Very good. How do sine and cosine relate to the sides of a triangle? We just talked about this. This is opposite over hypotenuse, and this is adjacent over hypotenuse. So, let's draw a right triangle. I call this theta because we need to know that this is the opposite, the adjacent, and the hypotenuse. So now using my Pythagorean theorem, instead of a, b, and c, I'm going to say opposite squared plus adjacent squared equals hypotenuse squared. That's just my a, my b, and my c. Right? Good. Glad you got that. Now wait, hold it. I want opposite over hypotenuse and adjacent over hypotenuse. So that means I want to divide everything by hypotenuse. But since these are all squared, I actually want to divide by hypotenuse squared. So if I divide each of these by hypotenuse squared, because algebraically if I do one thing to one piece of an equation, I have to do it to every piece. Now, what am I left with? I'm left with opposite squared over hypotenuse squared, which is actually just sine squared theta, plus adjacent squared over hypotenuse squared, which is cosine squared theta, equals, what is anything divided by itself? That's 1. Very good. This right here is our first Pythagorean identity. We have 2 others. We'll talk about those in a second. We did talk about them again in the summer review. But this one is crucially important. If you know this, it's really easy to know the other 2 from quotient and reciprocal identities. This is very, very important. Now, I want to point out, this identity only works if these are squared, because it comes from the Pythagorean theorem. Remember that a squared plus b squared equals c squared. A plus b does not necessarily equal c. Sorry, I still had it on that funky pen. I just got so excited. A plus b does not equal c. I mean, maybe it does. Probably not, though. So the Pythagorean theorem only works if the terms are squared and it's a right triangle. The Pythagorean identity, it's not just a fun name. There's a reason it's called Pythagorean, and that is because it comes from the Pythagorean theorem. So this only works if it's sine squared theta plus cosine squared theta, and then equals 1. Now, another thing I want to point out, this is just a notation thing. Sine squared theta is the same thing as sine of theta squared. We just write it like this, usually, so that we understand that it's the whole quantity squared, like what we see here. It is not the same thing as sine of theta squared. That's why we don't write it like this, because this is actually squaring theta. This is squaring the quantity sine of theta. This is squaring the quantity sine of theta. Important details. Alright, so this is our first Pythagorean identity, which is what I would refer to as our main Pythagorean identity. The other 2 Pythagorean identities come from taking this, but dividing them by, and again, I can look back up here at what I wrote in the red, or I can look at the identity. So if I look at what I wrote in the red, instead of dividing by hypotenuse squared, I could divide by opposite squared, or I could divide by adjacent squared. Another way to think about that, in terms of trig functions, if I look at what I have here in the black, if I divide this entire equation by sine squared, so let's do this. Now, look at what we developed. Oh my god. 1 plus cotangent squared theta equals cosecant squared theta. Another Pythagorean identity. And let's go back one more time. One more time. Encore. Encore. And now let's instead divide by cosine squared. Yeah, I knew you had that. Tip of your tongue. Cosine squared. Which leads us to tan squared theta plus 1 equals secant squared theta. So, those are our 3 Pythagorean identities. Again, it is not about memorizing them. I will be totally honest with you. I mean, granted, I've been teaching this for quite a long time now, so I do kind of have them in my head. But this one right here, this is the one I have memorized. And then the work that I showed you right here, I do that in my head to think about the other ones. Alright? So it's not about memorizing. It's about understanding, learning. Okay, so make sure you know and love. That's the important part. It's all about the love. The 6 reciprocal, the 2 quotient, and the 3 Pythagorean identities.